All right, guys, we're going to go over the rest of this packet for vectors number 2. Just a reminder, we finished the first page. I did want to show you real quick example number 4 here that we covered in our notes. We didn't do anything where we did a minus 3c. We did c minus b over here. So when you have something like 4, let's find 3c first, which would be 3 times negative 4, 5. I'm getting that from up here. So that's going to be negative 12, 15. And now I want to do a plus that. So I want to do this vector a, negative 6, 2, plus my vector 3c. And we want to add the x values together, the y values together. That'll get you your, let's see, it should be minus. So subtract your x values, subtract your y values, you got your new vector. So a couple more examples for you that you can practice with. We're going to jump into unit vectors. So think about the unit circle. That means a circle with a radius of 1 unit. A unit vector, same thing, has a magnitude of 1 unit. So that's called a unit vector. So it could be going in any direction. It doesn't have to be in a specific direction. Now, if we have a regular vector and we want to kind of shrink it down to be a unit vector in the same direction as the original vector. So for example, let's say I had like a vector q and I wanted to shrink that down so that it landed on top of vector u, this unit vector. We can find any unit vector in the direction of another vector by this formula. U, which is a unit vector, is going to equal 1 over the magnitude of our original vector v, and then I'm going to multiply that by v. And it seemed a little confusing. It's actually not as bad. Let me do number 7 here. So what I want to do is find a unit vector u in the same direction as the given vector. So negative 5, 12, if I sketch that, negative 5, 12, that's in quadrant 2, right? I go negative 5, so left, 12 goes up. I want a vector going in that same direction, but I want to shrink this down so it has a magnitude of 1. First thing I want to do is find the magnitude of v. This is a 5, 12, 13. So I know it's going to be 13, but let's find it. 25 plus 144 gets me 169, which comes out being 13. So my magnitude's 13. So using this formula, my unit vector in the direction of negative 5, 12 is going to be 1 over 13 distributed into negative 5, 12, which is going to equal negative 5, 13, 12, 13. So this final vector, u, we could check the magnitude of that by using your formula. You'll see that that does have a magnitude of 1. So you got a couple more problems you can try there. 11 and 12 are similar. I won't do all of these, but first we want to find v, which is going to be using points A and B, terminal minus initial. So don't forget, first we need to find our vector in component form. So I think that'd be 6, 6. And then of course you could find u from there. Okay, so you got plenty of ones you can try there. Next, let's talk about standard unit vectors. So standard unit vectors, first one, we have this vector called I. It has component form of 1, 0. It's our unit vector that goes exactly 1 unit to the right, does not go up or down. Then we have this other vector j. These are not variables, these are specific vectors. So vector j, similarly, it's a unit vector because it's a magnitude of 1. It's going straight up, so it has no horizontal component. So we can build any vector by using a combination of these 2 unit vectors. And another format that we're going to use is called a linear combination. And any vector v with component form. A comma B can be written as a linear combination as A I plus B J. It has A unit I vectors and B unit J vectors, and that makes up the entirety of it. So I don't think we need to go through this entire process. I'm just going to show you very simply how we can find a linear combination. So if I look at number 1 here, this is very simply 2i plus 5j. 2 should be really easy. 3, same thing. First I want to find component form. So I think if I call this vector v, component form should be 4, I'm doing terminal minus initial, 4 comma 14, that you can then translate to 4i plus 14j. So go ahead and try 2 and 4. We're going to skip trig form. You guys could probably figure that out. But let's jump down to 5 through 8 here. Component form. If you're given magnitude and theta, can be written as magnitude cosine of theta, comma, magnitude sine of theta. So if I know magnitude of 8, angle of 60 degrees, component form is going to be 8 cosine 60 degrees, comma 8 sine of 60 degrees. And let's plug those in. Degree mode. Getting 4. .93. Okay, so that is going to conclude the notes. Check the calendar and subplans, and you guys will see you'll have some homework 2 problems to do, which is at the back of your packet. Thanks, guys.